Hello everyone, I am apuPankaj and in today's video I will discuss the question and answer of exercise 1.1 of the chapter sets. Let's proceed. Okay, here the question is which of the following are sets? Justify your answer. The first example of set is the collection of all the months of a year beginning with letter J. Is it a set? Yes, of course. So I am writing my reasoning. This is a set because the collection is well defined. It includes January, June and July. These months starts with letter J. Correct. Now the second question is the collection of 10 most talented writers of India. So is it a set? Uh, we know that if a phrase is to be a set, it must be a well defined collection. Correct. But here most talented writers is not well defined. I want to say that this lacks a clear and objective definition of what constitutes a talented writer. That means talent is subjective concept and there is no universally accepted standard for determining who is a talented writer. Are you getting me? The phrase 10 most talented writers can be interpreted in different ways. Your list might be different than mine. Correct. So I am writing here this is not a set. This is not a set. The term most talented is subjective and can vary from person to person. Correct. Therefore this collection is not well defined. Now next question is a team of 11 best cricket batsmen of the world. Is this phrase a set? If you read this phrase carefully, you will find out that this phrase lacks a clear and objective definition of what constitutes the best cricket batsman. The concept of best is subjective and vary depending on individual preferences, criteria and perspective. I mean there is no universally accepted standard or metric for determining who are the 11 best cricket batsmen in the world, right? And this makes it difficult to definitely identify and include specific players in this collection. Okay, so your collection of the best cricket batsmen of the world might be different from another one. Another one might be suggest different player, different cricket batsman according to his preference, his criteria and perspective, right? So this is not a set because the term best is subjective and can vary based on personal opinions and criteria. Correct. So the next phrase is the collection of all boys in your class. Now you can list all the boys in your class and your list have to be same as others. You might arrange them in different orders but the same boys will be included in everyone's set. Correct. So this is a set. This is well defined. This is a set because the collection is well defined. It includes all the male students in your specific class. Correct? The next phrase is the collection of all natural numbers less than 100. Now this collection is also well defined. So this is also a set. This is a set because the collection is well defined. It includes all the natural numbers from 1 to 99. That is 1, 2, 3, 4, 5 up to 99. Okay. Remember that here the ellipses, I mean this triple dot indicates that the pattern established by the first few numbers continues up to 99. So this set includes all the natural number from 1 to 99. Okay. So the next phrase is a collection of novels written by the writer Munshi Premchand. It is also well defined. This is a set because the collection is well defined. Everyone knows which novels is to include in the set of the novels written by Munshi Premchand. That means the set will be include Godan, Nirmala, Kafan and Karmabhumi. Here the next phrase is also an example of set, the collection of all even integers, though it contains infinitely many number of elements, but the elements are clearly defined. That means these elements are a multiple of 2. That means I can write them in the form of 2n. So I can write here this is a set because the collection is well defined. It includes all the numbers that can be written in the form of 2n, where n is an integer. That is, if you take n is equal to 1, the element will be 2, and if you take n is equal to 2, the element will be 4. If you take n is equal to 3, the element will be 6, and if you take n is equal to 4, the element will be 8, and so on. N is an integer, means 1 2 3 4 5 6 etc. Next phrase is the collection of questions in this chapter. This is also an well defined collection, and you can include all the question of this chapter in this set, so that's why this is also an example of a set. Correct. So here I am writing that the collection is well defined. It includes all the questions that are present in this specific chapter. The next phrase is a collection of most dangerous animals of the world. Is this phrase a set? No, it is not considered as a set. Why? Due to the ambiguity and subjectivity inherent in the concept of dangerous. Uh, what does that mean by? That means determining which animals are the most dangerous in the world is a complex task that involves various factors including the animal size, strength, venom, habitat and behavior. Correct. These factors can vary greatly among different animal species. Okay, and that's what make it challenging to establish a clear and objective criterion for measuring dangerous. Okay, so dangerous is subjective and can be influenced by individual perspectives, experience and cultural context. That means what one person considers a dangerous animal may not be considered a dangerous by another. So if you consider cheetah as a dangerous animal and you consider cheetah as the most dangerous animal of the world, your friend might not be agree with your decision. Your friend might say that venomous spider is the most dangerous animal of the world. So this subjectivity makes it difficult to create a universally accepted list of the most dangerous animals. And that's what adds the vagueness of the collection. And we cannot consider this collection as a set. I am writing exactly that in a brief way. This is not a set. The term most dangerous is subjective and can vary based on different criteria such as the number of human fatalities per year, the toxicity of their venom, etc. Therefore, this collection is not well defined. That means this is not a set. Let's proceed to question number 2. Question number 2 is a very simple question. Here A is a set and it has 6 elements 1, 2, 3, 4, 5, 6. Insert the appropriate symbol, that means belongs to or not belongs to, in the blank spaces. So it is very easy. If you find this element inside the set, you will put this symbol here, and if you cannot find the element, you put this element here. So I am writing the answer here. These are the answer. Now let's proceed to question number 3. The second question is b is equal to x such that x is a natural number less than 6. So here I will list all the natural numbers that is less than 6. That means 1 to 5. Here b is equal to 1, 2, 3, 4, 5. Number 3i is c is equal to x such that x is a 2-digit natural number such that the sum of its digits is 8. So here I will list all the 2-digit natural numbers. The sum of the digits of the natural number must be 8. And these are the natural numbers whose digits add up to 8. That means 1 plus 7 is equal to 8, 2 plus 6 is equal to 8, 3 plus 5 is equal to 8, 4 plus 4 is equal to 8, 5 plus 3 is equal to 8, 6 plus 2 is equal to 8, 7 plus 1 is equal to 8, and 8 plus 0 is also equal to 8. Remember here you cannot write 0, 8 because 0, 8 is a single digit number. Okay, 0 contains no value if it is written on the left of 8. The next question is d is equal to x such that x is a prime number which is divisor of 60. Okay, I am writing that. So this can be written as d is equal to 235. Okay, so if you divide 60 by 2, 3 or 5, the remainder will be always 0. So these are the divisor of 60, 2, 3 and 5. And these are also the prime numbers as mentioned in the set. And remember that 4 and 6 and 10 are also divisor of 6. Not only that, but also 12 and 15 and 20 and 30. These all are divisor of 60. But these 4, 6, 10, 12, 15, 20, 30, these are not prime numbers, correct? So according to the set I have to include only prime numbers. Prime number which number has only 2 factor, 1 and itself. So 2 has 1 and 2, 3 has 2 factor, 1 and 3, 5 has 2 factor, 1 and 5. Okay, the next question is E is equal to the set of all the letters in the word trigonometry. Remember, in a set I cannot repeat one element more than once. I cannot repeat any element. So I will list all the letter and I will take care that I am not repeating any of the element. Okay. So this can be written as E is equal to TRIGON. Here I cannot write O once again. M E, here also I cannot write T once again, and I cannot write R once again. At last Y. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9 elements in the set of E. Correct. Finally, the set F denotes the set of all letters in the word better. Here I have to follow the similar convention. That means sets are collection of distinct objects, so each letter would only be listed once. Okay, so I am writing that. This can be written as F is equal to BETR. Here I am not repeating T twice. Correct. Let's proceed to question number 4 now. Now let's solve the questions of question number 4. Question number 4 is write the following sets in the set builder form. So you know that in set builder form we describe all the elements of the set by a property common to all of them. So we will find out what is the common property of all the elements of a set. Let us first consider the first set, and as you can see this is mentioned in listing method. Now I am going to write the same set in the set builder form. Here if you observe each of the element of this set carefully, you will find out that each element of this set is a multiple of 3. That means 3 times of a natural number. Okay, that means 3 is 3 times of 1, 6 is 3 times of 2, 9 is 3 times of 3, 12 is 3 times of 4. That means if small n is a natural number, then these elements is equal to 3n. 3n means n multiplied by 3 is equal to 3n. So you can get each of the element of the set by multiplying 3 with a natural number. Here n is a natural number. So I am just explaining you what are the common property of the elements of the set. So now let's write the set in set builder method. So this can be written as x such that x is equal to 3n. Here n is a natural number, so I can write n belongs to capital N. You know that capital N denotes the set of natural number, right? And the natural number which is being multiplied by 3 is less than or equal to 4. So you know there are 4 natural number which is less than or equal to 4. They are 1, 2, 3 and 4. So if I substitute 1, 2, 3 and 4 in place of n, I will get 3, 6, 9 and 12. Let me write this set in another way. This set can be written in this way also. This is a short way of writing the same set. And here if I will take n is equal to 1, then 3n will be 3. Remember that the element of the set is equal to 3n. So these all are equal to 3n, and n is a variable which is less than or equal to 4. Now 1 is less than or equal to 4, and if I will substitute 1 first, I will get 3 into 1 is equal to 3 here. Similarly, if I substitute 2 in place of n, then it will become 3 into 2, 3 into 2 is equal to 6. So 3n will be 6. Similarly, if I will substitute 3 in place of n, here I will get 3 into 3 is equal to 9. Correct. So here the element will be 9. Similarly, the final value of n will be 4. So when the value of n will be 4, the value of 3n will be 12. 4 into 3 or 3 into 4 is equal to 12. So these are the elements of the set, and these are the possible values of n, and I have just mentioned that in the set builder method. Now let's proceed to the next question. So what is the property that is common to all the elements of this set? If you look carefully, you will find out that each element in the set is 2 raised to the power of a natural number, say n. this is 2 to the power 1, and this is 2 to the power 2, this is 2 to the power 3, this is 2 to the power 4, and this is 2 to the power 5. Okay, so if I will take n is equal to 1, 2 to the power 1 is equal to 2, and similarly if I will take n is equal to 2, 2 to the power 2 means 2 multiplied by 2 is equal to 4. Similarly n is equal to 3 means 2 to the power 3 is 2 into 2 into 2 means 8, and n is equal to 4 means 2 to the power 4, 2 multiplied by 2 multiplied by 2 multiplied by 2 means 16. And finally if n is equal to 5, 2 to the power 5 is 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 2. So 5 times 2, 2 multiplying 5 times means 32 is the answer. So the value of n is all the natural number less than or equal to 5, and all the elements are 2 raised to the power something. Okay, first one is 2 raised to the power 1, second one is 2 raised to the power 2, third one is 2 raised to the power 3. So I can write this set as x such that x is equal to 2 to the power n. Here n is a natural number and n is less than equal to 5. Correct. All the natural number that is less than or equal to 5 raised to the power 2 are the element of the set. Okay, let's proceed to the next question. Just like the previous question, the element of this set is 5 raised to the power of a natural number, say n, and here n is a natural number which is between 1 and 4. Correct. So if I will give you some examples, when the value of n is 1, the element will be 5. 5 to the power 1 is equal to 5. Correct. Similarly, when the value of n is 2, the element will be 25. 5 to the power 2 means 5 multiplied by 5 is equal to 25. Similarly, when the value of n is 3, the element will be 125. That means 5 to the power 3 is equal to 125. And when n is equal to 4, 5 to the power 4 is equal to 625. So these are the element of the set. So what you are observing here, the value of n is varying between 1, 2, 3, 4. Okay. So when the value of n is 1, 5 to the power n, that means 5 to the power 1 is equal to 5. When the value of n is equal to 4, the value is 5 to the power 4 means 625. Okay. So we can write here, that x such that x is equal to 5 to the power n, and here small n is belongs to capital N. That means small n is a natural number that less than or equal to 4. Okay. Now tell me, what is the common property that associate to all the element of this set? If you observe carefully, you will find all the element of this set is 2 times of a natural number. Correct. I mean, if n is equal to 1, then its 2 time will be 2 into 1 is equal to 2. And if n is equal to 2, 2n is equal to 4. Similarly, when n is equal to 3, 2n will be 6, and so on. Here you can observe small n is a natural number and that goes on and on up to infinity, and like that 2n is also increasing, and the elements are a multiple of 2, that means 2 times a natural number. So the above set can be written as x such that x is equal to 2n, that means all the number are even numbers, and small n belongs to capital N, that means small n which is being multiplied by 2 is a natural number. Let's proceed to the next question. Okay, look at the elements of this set carefully and tell me what is the common property you observe in all the elements. Right, the common property is all the element is a square of a natural number. This is square of 1, this is square of 2, this is square of 3, and this is square of 10. So if small n is a natural number, here n square is the element of this set and the value of small n is between 1 and 10, containing both of them. Okay, so the above set can be written as x such that x is equal to n square. Here small n is a natural number, that means small n belongs to capital N, and n less than equal to 10. Okay, we are squaring up to 10. This is square of 1 and this is square of 100. Now I am giving you some example for more clarification. Let small n is equal to 1. So what will be n square? N square will be 1. 1 square means 1. If n is equal to 2, n square means 2 square. 2 square will be 4. If n is equal to 3, 3 square means 9. Square of 3 is 3 multiplied by 3 is equal to 9. And so on. At last I will write n is equal to 10. This will be the last element of this set. And if n is equal to 10, n square is equal to 10 square, means 10 multiplied by 10 is equal to 100. So these are the elements of this set and these are the values of n. N is a natural number between 1 and 10. So as I have already mentioned, small n is a natural number. I don't have to write n is greater than 1 because all the natural number are greater than 1. Okay, now proceed to question number 5. Here the question is a is equal to x such that x is an odd natural number. We know that there are infinitely many odd natural number like 1, 3, 5, 7 and so on. So we cannot list all of them, but the pattern is like this: a is equal to 1, 3, 5, 7, 9, 11, 13, 15. These numbers are not divisible by 2, that's why these are odd numbers. There are infinitely many odd natural number, so I just have mentioned up to 15, and after that I have mentioned that there are infinitely many natural number by these 3 dot sign at last. Next, here if x is an element of set B, x is an integer and x lies between minus 1 by 2 and 9 by 2. Let me first draw a number line to explain you in detail. Suppose this is a number line and I have marked some integers here like minus 2, minus 1, 0, 1, 2, 3, 4. These are the integers. But in order to find some integers between these fractions minus 1 by 2 and 9 by 2, I first marked minus 1 by 2. Between 0 and minus 1, you know that this is half negative, means I have to divide the portion from 0 to 1 into 2, and the midpoint is minus 1 by 2. And I am mentioning another point, that is 9 by 2. You know 9 by 2 is a improper fraction. If I will convert this into a mixed fraction, this will become 4 whole 1 by 2, correct? Means total 4 and half of another. 4 whole 1 by 2, where will it remain? It will remain here, correct? So I am marking the point. Here is the point, as you can see. And can you tell me what are the integers between these two fractional number? Yes, these are 0, 1, 2, 3 and 4, correct? So these integers are between minus 1 by 2 and 9 by 2. I can write that. So the integers that are both greater than minus 1 by 2 means which integers are to the right side of minus 1 by 2. These are greater than minus 1 by 2, and less than 9 by 2 means the integers that are at the left side of 9 by 2 plus 9 by 2. These are the integers. What are the common integer, or what are at the intersection of right side of minus 1 by 2 and left side of plus 9 by 2 or 4 whole 1 by 2? These are the integers 0, 1, 2, 3. Therefore I can write b is equal to 0, 1, 2, 3. So 0, 1, 2, 3 and also 4. These are the numbers that lies between minus 1 by 2 and 9 by 2. Okay. Here in set C, according to the description, if x is an element of this set, the square of x must be less than or equal to 4. We know that if x is a non-zero integer, its square will be positive always. X may be negative or may be positive, but the square of x will be always positive. That means the square of any integer x is x square. If we are looking for integers x such that x square is less than equal to 4, then we can substitute minus 2, minus 1, 0, plus 1 and 2 in place of x. So we know that these square are less than or equal to 4. Both minus 2 square and plus 2 square are equal to plus 4. Both minus 1 square and plus 1 square are equal to plus 1, and 0 square is 0. Okay. So these numbers, these perfect square number are less than or equal to 4. So the integers whose squares are less than or equal to 4 are minus 2, minus 1, 0, 1, 2, and these will be inside the set of C. Okay. Now let's proceed. Here set D will contain all the letters in the word loyal. The distinct letters in loyal are L, O, Y, A. Here which letter is repeated twice? L. So I won't write that twice. Okay. The set of all distinct letters in the word loyal is L, O, Y, A. That means D in listing method will be written like this. Okay. Now let's proceed. Here set E will contain all the month of a year not having 31 days. The months that do not have 31 days are February which has 28 or 29 days, April which has 30 days, June which has 30 days, September, November also has 30 days. So the set of all months of a year not having 31 days are February, April, June, September and November. So that will be listed inside set E. Next. Finally, in set F, we will list all consonants in the English alphabet which precedes K. Letters in the English alphabet are A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y and Z. And the consonant which precedes K are B, C, D, because A is a vowel, we will not consider A. Similarly, E is vowel, so we will not consider E. So first B, C, D and then F, G, H, I, J. These are the consonants that precedes K. Okay. The set of all consonants in the English alphabet which precedes K are B, C, D, F, G, H. F is equal to B, C, D, F, G, H. Now let's proceed to question number 6. Match each of the set on the left in the roster form with the same set on the right described in set builder form. Okay. So the left side column contains all the set in roster form and right hand side column contains all the set in set builder form. We have to match them. Let us consider the first set in roster form, that is a set has 4 elements inside it and the elements are 1, 2, 3, 6. What are the common property? So if you observe carefully, you will find out that all these elements are natural number. Not only that, they all are divisor of 6. That means if you divide 6 by any of these elements, the remainder will be always 0. And these are natural number obviously. So I know I will be matched with C. I am doing exactly that. This will be matched with this. The second question is 2, 3. I mean the second set has 2 elements inside it and they are 2, 3. And what are the common property of these elements? Look carefully. These 2 elements are not only divisor of 6 but also a prime number. Prime number means the number which has only 2 factor. Like 2 has 1 and 2 as its factor. 3 has also 2 factors. One is itself and another is 1. Okay, one factor is 3 and another is 1. So these two will be matched. This will be matched with option A. Third question, the third set has all the letters of the word mathematics. Correct? M-A-T-H-E. M has not repeated twice according to set theory and ICS. So obviously this will be matched with question D. So I am matching them. Correct? Similarly, the last set has 5 elements and they are 1, 3, 5, 7, 9. Obviously these all are odd natural numbers and these are less than 10. So these two will be matched. Okay, that's all for today's video.